So this video is an introduction to the activity that you are going to be doing with a partner. So you need to find someone that's at the same place as you, and then you need to go through these activities that look at exponential growth and decay. And so there's a few different activities you're going to do. The first activity, ask your teacher for some cereal, and you're going to be given 15 seconds to try to eat one piece of cereal. So that's pretty easy. No big deal. Then you're going to be given 15 seconds and try to eat 2 pieces of cereal. Again, no big deal. If you can do it, just move on. Don't wait for the 15 seconds to go up. Then you're going to have 15 seconds to eat 4 pieces of cereal. Should be able to do it, no problem. Then you're going to have 15 seconds to eat 8 pieces of cereal. You're going to keep doing this. So you're going to get 15 seconds to eat 16, and then 32, and then 64. And at some point, you're going to not be able to keep up. A couple rules with the eating of the cereal. You can't just shove all the pieces in your mouth. You got to eat them one at a time, and you have to swallow them before you can eat the next one. And so that's going to obviously slow you down a bit. So what I want you to do is try the activity, pause the video, and then compare your answers to the ones that are going to be in the video. So just pause the video right now, go through the activity, and then restart the video, and you'll see your answers and you can compare. So hopefully you had fun enjoying eating the cereal. And what you probably noticed was as you ate the cereal, as it doubled and it doubled, at first it was really easy, then it got a bit harder, then it got really hard, and then you just couldn't keep up anymore. And that's kind of what exponents are like, right? They start off small, and then they get a little bit bigger, and then suddenly it's like they take off like a rocket ship. And so this particular example, this particular activity is an example of exponential growth. What's happening is we're getting bigger. As the trial number increased, we doubled and we got bigger. And what you experienced by eating that was you actually experienced what exponential growth would feel like, and how much it starts easy and then how quickly it can get out of control. And so just look at your answers, make sure that you're on the right track, and call your teacher over if you have any questions. So let's look at the second activity then, a little bit less exciting. They kind of go in order from the most exciting to eating the cereal. So this particular one, you're going to be given 2 options. You can get $20 a day for allowance, or you can double the amount of money you get each day. And so you'll notice the 2 options are outlined in these tables. All I want you to do is fill in the rest of the blanks and then graph it. And you're going to graph them on the same grid. If you have 2 different colors in your pencil case, use different colors, like maybe a pencil for one and a pen for the other, or 2 different colors of pencil crayon, that kind of thing. And you're going to be able to look at what you get and compare them, and then you'll have a chance to answer some of the questions. And again, pause the video, try it out, and then restart it, see your answers and compare them. So here, what you should have gotten, just a note, and I should have mentioned this, graphing it is going to be a little bit tricky because you're going to have to estimate. It's going to be really hard to have a scale that's going to fit perfectly. And so you'll notice my picture here is kind of a rough sketch and a bit of an estimation of where the dots are. So don't stress out if you can't get each dot perfectly. And so when you look at these, option 1 at first starts really slowly, and you're way behind. The person that chose option 2 would be thinking, wow, you're kind of silly here, like why did you choose this? You're losing out. But suddenly, around day 8, something very interesting happens. So day 8, option 2 is still better, but not as much. And then day 9, whoa, suddenly look what happens. And then by day 10, holy moly. And if this continued, it would be even more dramatic. So what you can see is the one on the right, option 2, we call this one a linear growth. It's a straight line. It goes up by 20 every time. The one on the left, we would call exponential growth. It starts super small. It starts really slow. It's almost painfully slow. And then suddenly it shoots up like a rocket. So if you had only 5 days to make a choice, obviously you would choose option 2. But if you're looking at 10 days, 11 days, 20 days, like imagine what's going to happen after a month of doing this. So what this tells you, again, is that exponential growth starts small, but in the end, it gets really big really fast. So that's kind of what this one's looking at. It's comparing a linear growth model to an exponential growth model. So let's look at, there's one more activity, which is activity 3, which is cutting paper. So what you're going to do is you're going to get a piece of paper, and you're going to cut the paper in half, and then you're going to cut it in half again, and cut it in half again, and cut it in half again. As you cut the paper, you're just going to put the piece you cut aside. So you're going to keep going so that your paper gets smaller and smaller and smaller. You're going to fill in the chart, you're going to graph it, and you're going to answer the questions. Again, pause the video, restart it when you're done, and then you can see if you're on the right track. If you need any help, call your teacher over. So in this one, you'll notice that as you kept cutting, the paper gets smaller and smaller until probably you really couldn't cut. Like down here, you might not have even been able to cut that much. And then when you graph it, you're going to notice, again, this time it takes a dramatic drop really quickly, and then it levels out really slowly. Technically speaking, if you kept doing this, you would always have some paper. In reality, no. It's, you might have a grain or a tiny little bit, but in technically speaking, in terms of mathematically, if you keep halving something and halving something and halving something, there will always be something left, even if it's like microscopic. And this is an example of exponential decay. And the difference between exponential growth and exponential decay is that here the numbers are getting smaller. So growth, we're getting bigger, we're doubling or tripling or quadrupling, and decay, we're getting smaller, we're halving or a quartering or things like that. So have a look, call your teacher over if there's anything you're not sure about. And so now let's look at a summary of all of these activities that you did. So it talks about in your group. So again, you should be working with a partner or maybe a couple different partners. So I want you to discuss what you think exponential growth and decay is. Give some examples of what you think. And then we're going to look at this chart here at the bottom. So try to discuss number 1 first, and then we'll pause the video, discuss number 1, restart the video, and then we'll talk about number 2. So exponential growth is, again, you're getting bigger, but you're getting bigger in a very particular way, because linear growth, you're also getting bigger. Think of the example with the allowance, right? You're getting bigger, but you're not getting bigger, you're just getting bigger $20 every day. Exponential growth is getting bigger by doubling or tripling, and so it starts small and then it will get really big really fast. Population growth, that can be an example of exponential growth. Also growth over time in the stock market. So not the day-to-day ups and downs of the stock market, but if you looked at historical trends of the stock market, they say if you put your money in, that every 7 to 10 years, depending on what the interest rate is, approximately every 7 to 10 years, your money will double. And so if you historically looked at your money, left it, and then looked at what happened to it, over the course of about 7 to 10 years, over the course of history, your money would double, and that would be an example of exponential growth. You may have come up with some other ones. Exponential decay, again, we're getting smaller, but again, getting smaller in a particular way. We're getting smaller by halving or quartering or that kind of thing. Some examples, March Madness, right? Playoffs, basketball playoffs, hockey playoffs, all of those kinds of things. March Madness, you start with 64 teams, then you're down to 32 teams, then you're down to 16, then you're down to 4, then 2, then 1. That's an example of exponential decay. Also, there's a lot of radioactive materials that have something called a half-life, which means every 20 minutes or every hour, or it's dependent on the actual radioactive material, it will half. And so that's an example of exponential decay. So what you're going to do for question 2 is you're going to fill in the table of values, and then you're going to graph them on the graph paper. What I want you to do is definitely use your calculator. Do not go with what you think. So for example, 2 to the exponent of -1, it might not be what you think it's going to be. So please punch it into your calculator, and then double check your answers before you go ahead and graph them. So pause the video, put it in your calculator, restart the video to check your answers before you graph them. So here are the answers, and again, hopefully you used your calculator, and you might notice a few surprises. And don't worry too much about this. We're going to spend some time in this unit looking at some of these answers and why they are what they are. But one of the big surprises, hopefully you noticed, is that 2 to the -1 isn't -2, and you might have thought it was, but it's not. Remember this one here, anything to the exponent of 0 is 1. And this is an example of exponential growth. We're getting bigger, we're doubling. This one, again, might be some surprises that when you put a half to the -1, you got an answer of 2, which you might think is kind of weird. And then what happened is your answers actually got smaller as time went on. This one is an example of exponential decay. So I want you to graph them on your graph paper and pause the video. And so pause it and then restart it and check that you got it right. So your graph should look something like this. They have different scales, so they're going to look slightly different, but you'll notice that this one will have a growth and this one will have decay. The other thing that you should notice is both graphs do go through the point 0, 1, and that's something that is particular to exponential graphs, because anything to the exponent of 0 is 1. So all exponential graphs will go through the point 0, 1. So this was just an activity to get yourself thinking about exponents, get yourself ready for the exponent unit. So move on to the next activities. Hopefully you had fun with this one and you'll learn something about exponents.